Okay, I'm going to split section 6.2 into two parts. The second part's going to start with trees. So what we have now is our edges are now going to be numbered, and these numbers are going to be the weights of the edge, how much it costs to go on that edge, how much time it takes to go on that edge. It could be any number of things, but the weights on the edges signify some characteristic about the edge. Now the length of the edge does not have to correspond with the weight of the edge. If we look here, 67 is a large weight and 1/2 is a very small weight, but they're essentially the same length. So the weights and the length of the edge, they don't have to correspond. Just keep that in mind. Okay, suppose Ed has a 35-minute drive from his home to his workplace, and a 15-minute drive from his workplace to his health club, and a 25-minute drive from his health club to his home. We want to draw a weighted graph to represent this. So we have his home, his workplace, and his club. So home to workplace is 35 minutes, so the weight of that edge is going to be 35. Workplace to health club has a weight of 15, and from health club to home is 25. So that's a weighted graph that represents the characteristics that we were given. A subgraph is any set of vertices and edges that come from the original graph. So here we've taken out the club to home, the health club to home. We've taken out that edge, and now we have a subgraph. We could take out even more, and we're left with just home to work and the edge that has a weight of 35, and it is also a subgraph. Okay, in this example we have a bus line that goes between the cities shown in the table, and we need to draw a weighted graph to represent the situation. So we have Birmingham, Gadsden, Anniston, Selma, and Montgomery. So Birmingham goes to Gadsden, which is 66. Birmingham goes to Anniston, which is 62. Birmingham goes to Selma, which is 160. Okay, try that again, 160. And Birmingham to Montgomery is 91. So we finished all the Birminghams this direction, and likewise this direction. So Gadsden to Anniston is 27. Gadsden to Montgomery is 127. So we finished Gadsden in both directions. So all that's left is Montgomery to Selma with 49. So Anniston, these were finished. Selma to Montgomery finished. Montgomery to Selma, same amount. So find two different routes from Selma to Anniston. So if we start at Selma, we could go Selma, Birmingham, Anniston. So that would be 160 plus 62. The cost of that trip was $222. We could go Selma, Montgomery, Gadsden, Anniston. Selma to Montgomery is 49. Montgomery to Gadsden, 127. Gadsden to Anniston, 27. So that's 23 carrier 2, 4, 6, 8, 10. So that's 203. So that's two different routes from, or paths from Selma to Anniston. And we'll start here with the next group.